Good morning, everyone, and thank you for being here today. I'm excited to introduce our presentation on disinfectant rotation strategy and aseptic processing. My name is Dr. S.K. Singh, and I hold a PhD in this field. Over the next few minutes, we'll explore effective strategies to optimize disinfectant use in aseptic environments, ensuring safety and compliance. We'll cover key concepts, practical approaches, and best practices to help you enhance your processes. Let's get started. Welcome to this next section where we focus on aseptic processing. As you know, maintaining microbial control is absolutely essential to ensure product safety and quality. Disinfection plays a critical role here, serving as one of the key contamination control measures we rely on daily. Now, to enhance the effectiveness of our disinfection efforts, we implement a rotation strategy. This means we plan to use multiple disinfectants instead of sticking to just one. The idea is to prevent microbes from developing resistance, which can happen if we use the same disinfectant repeatedly. This rotation strategy isn't just an isolated tactic. It's an integral part of our overall contamination control strategy, or CCS. When we combine these approaches, we create a more robust defense against contamination, helping us uphold the highest standards in aseptic processing. So, as we go along, keep in mind that this strategy is about being proactive and adaptable in controlling microbial threats, ensuring the safety and efficacy of our products. Let's talk about why disinfectant rotation is so important. First, if we use the same disinfectant repeatedly, there's a risk that its effectiveness can decrease over time. Microorganisms can develop resistance or adapt, making the disinfectant less effective. That's why switching things up helps maintain a high level of cleanliness. Another key reason is to address the diverse types of microflora present in different environments. Different microorganisms require different approaches, so rotating disinfectants ensures we're covering all bases. It's important to remember that we need to ensure coverage against various types of microbes, including vegetative bacteria, fungi, and spores. Each of these can pose different challenges, and a single disinfectant might not be effective against all of them. That's the main idea. No single disinfectant is universally effective. Relying on just one can leave gaps in our infection control. By rotating disinfectants, we can improve our overall effectiveness and better protect our environment and health. Now, let's talk about the regulatory expectations around disinfectants. First and foremost, disinfectants must be validated for efficacy, meaning we need solid evidence that they actually work against the microorganisms we're targeting. It's also crucial that these disinfectants are appropriate for the specific microflora present in the facility, so they effectively control the microbial environment without causing unintended issues. Our program should include multiple disinfectant types. This diversity helps prevent resistance and ensures broader coverage. Additionally, implementing a defined rotation schedule is essential to maintain effectiveness over time and prevent microbes from adapting. When regulatory inspections happen, they will review several key documents. These include standard operating procedures, or SOPs, which outline how disinfectants are used. They'll also look at rotation records to verify that the schedule is followed properly. Lastly, validation data must be available to demonstrate that the disinfectants are effective and used correctly. Staying aligned with these expectations not only helps us remain compliant, but also reinforces our commitment to maintaining a safe and sterile environment. Let's take a closer look at the FDA expectations for disinfectants. Essentially, disinfectants must be effective against isolates from the facility, meaning they should be capable of eliminating the specific microorganisms identified within that environment. Additionally, for aseptic areas, the disinfectant must be sterile itself to ensure it doesn't introduce new contaminants. It's important to recognize some limitations as well. For example, alcohol-based disinfectants are not effective against spores, which are particularly hardy forms of microorganisms. This leads us to an important implication. Our disinfectant rotation needs to include sporicidal agents to effectively manage spore-forming bacteria and ensure comprehensive microbial control. Moving on to the European Union's GMP Annex 1 requirements, the standards are quite similar, but also emphasize some additional points. They recommend using more than one type of disinfectant, which helps prevent microbial resistance and broadens the spectrum of activity. Including sporicidal agents in your disinfectant regime is also strongly advised. Routine environmental monitoring plays a key role here, allowing us to track microbial trends over time and adjust disinfectant strategies accordingly. For example, in grade B and C areas, it's recommended to perform weekly sporicide use. This proactive approach helps maintain the integrity of sterile environments and supports overall quality assurance. Let's talk about the scientific basis of rotation in antimicrobial protocols. Microorganisms, as you know, don't all react the same way to disinfectants. For example, gram-positive bacteria tend to be more susceptible compared to gram-negative bacteria, which have an outer membrane that provides extra protection. Fungi and spores are even more resistant, requiring different approaches. Additionally, our environmental flora, the microorganisms naturally present in our surroundings, can change over time, which impacts how effective our cleaning methods are. By rotating disinfectants and antimicrobials, we can achieve a broader spectrum of activity, making sure we're covering a wide range of microorganisms. It also helps reduce the risk of contamination and the development of resistant strains. This rotation strategy is vital in ensuring our infection control measures stay effective and adaptive to evolving microbial landscapes. Now, let's take a look at the common categories of disinfectants we use. First, we have alcohols like isopropyl alcohol, or IPA, and ethanol. These are widely used because they act quickly and are effective against many microbes. Next are quaternary ammonium compounds, which are versatile disinfectants often used in surface cleaning. Then there are oxidizing agents, such as hydrogen peroxide, which break down microbial components through oxidation. Moving on, aldehydes like glutaraldehyde are powerful disinfectants, especially for equipment that needs high-level sterilization. Finally, we have sporicides, like peracetic acid, which are capable of destroying spores that are typically resistant to other disinfectants. In our routine cleaning protocols, we often rotate these disinfectants. For example, we might use IPA daily because it's fast and effective for quick surface disinfection. Hydrogen peroxide could be scheduled weekly, providing a strong yet safe option for deeper cleaning. And sporicides like peracetic acid might be used monthly to ensure spores are effectively eliminated. This rotation helps maintain high disinfectant efficacy and reduces the risk of microbes developing resistance, which ties back to our overall goal of maintaining a safe and sterile environment. Let's take a look at the rotation strategy design. The key elements here revolve around a risk-based approach, often referred to as QRM or quality risk management. This means that our rotation schedule is not arbitrary. It's designed thoughtfully based on the level of risk associated with different areas. We define the frequency of rotation, whether it's daily, weekly, or monthly, depending on several factors. One of the most important is the cleanroom grade, as higher grade environments require more stringent and frequent cleaning protocols. Environmental monitoring data also plays a crucial role. If monitoring indicates higher contamination risks, then more frequent rotations are necessary. Additionally, the type of surfaces within the cleanroom influences our strategy. More sensitive surfaces may need different cleaning regimens. For example, in a grade A environment, we typically use sterile IPA or isopropyl alcohol combined with periodic sporicide treatments. This approach ensures that we maintain the highest level of cleanliness and minimize contamination risks. Overall, this strategy allows us to tailor our cleaning and rotation schedule effectively, aligning with the overall goal of ensuring product integrity and compliance. Let's talk about the role of environmental monitoring in our process. Essentially, it helps us identify microbial trends over time, so we can see patterns or increases in certain microorganisms. It also allows us to detect resistant organisms, which is crucial for maintaining effective infection control. This monitoring doesn't just inform us, it actively drives change. For example, if we notice a rise in resistant organisms, it might lead us to reconsider our disinfectant choices or adjust how often we rotate disinfectants. These adjustments are key to staying ahead of potential issues. And from a regulatory perspective, continuous review and trending are expectations. Regulators want to see that we're consistently monitoring, analyzing, and responding to environmental data. So, environmental monitoring isn't just a checkbox. It's a vital part of our ongoing effort to ensure a safe and effective environment. Let's take a closer look at the validation requirements for disinfectants. First, it's essential that the validation demonstrates a significant reduction in microorganisms, typically a log reduction of 3 log or higher. This means we're aiming for a 99.9% reduction in the microbial load, which is a critical benchmark for efficacy. Next, we need to verify effectiveness on both facility surfaces and isolated microorganisms. This ensures that the disinfectant works not just in theory, but in real-world conditions, effectively reducing microbes on the surfaces we encounter daily. The validation process includes surface challenge studies, where we test the disinfectant's ability to handle challenging microbial loads on actual surfaces. We also need to validate contact time, meaning we confirm the amount of time the disinfectant must be in contact with a surface to achieve the desired microbial reduction. All of these components together help us ensure that the disinfectant is both effective and reliable in maintaining a safe environment. This thorough validation process ultimately ties back to our overall goal: safeguarding health through proven disinfection practices. Let's talk about SOP and documentation requirements. It's essential that written SOPs clearly define key procedures, starting with the rotation schedule. This ensures everyone knows when to rotate and helps maintain consistency. Next, the SOP must detail preparation and dilution steps, so the process is always performed correctly and safely. Contact time is also crucial. It specifies how long a disinfectant or treatment needs to stay effective. Now, when any of these elements change, it's important that those changes are approved before implementation. We also need to document every update thoroughly, so there's a clear record of modifications. Lastly, these updates must be reflected in the SOPs themselves. This way, everyone is working from the most current guidelines, which supports overall safety and compliance. Remember, maintaining clear, accurate SOPs is vital to ensuring consistent, effective procedures across the board. Let's look at some practical examples of rotation strategies. First, the standard rotation approach. Here, we have a daily use of 70% IPA, which is our regular disinfectant, followed by a weekly application of a quat-based disinfectant, and then monthly use of a sporicide to target spores. This routine helps maintain consistent cleaning and disinfection standards. Moving on to the trigger-based rotation, this method adjusts based on specific detections. For instance, if we detect Bacillus spp, which are spore-forming bacteria, we increase the frequency of sporicide use. This targeted approach ensures we respond effectively to potential risks, making our disinfection process more dynamic. Finally, there's seasonal adjustment. During the monsoon season, fungal counts tend to rise, so we introduce a fungicidal agent during this period. This flexibility allows us to adapt our disinfection protocols to seasonal variations and environmental conditions, ultimately enhancing our overall infection control strategy. These examples highlight how rotation isn't a one-size-fits-all, but a tailored approach that can be adapted based on microbial detection, environmental factors, and operational needs. It's all about being proactive and responsive to ensure maximum safety and efficacy. Let's take a closer look at some common audit observations we often encounter. One major issue is the absence of a documented rotation schedule. This can lead to inconsistent practices and make it difficult to verify that proper procedures are followed. Another point is the lack of sporicide use, which is crucial for effective sanitation and preventing contamination. We also frequently see poor validation data, which raises concerns about whether processes are truly effective and reliable. Additionally, inconsistent implementation of procedures can undermine overall compliance and quality. Now, moving on to key takeaways. First, rotation is an integral part of critical control points, or CCS, and GMP compliance. It's not just a procedural formality, it's essential for safeguarding quality. Second, all these activities must be driven by solid data and validated thoroughly. Without proper validation, we can't be confident that our processes are working as intended. Lastly, continuous monitoring and regular updates are vital. Compliance isn't a one-time effort. It's an ongoing process that requires vigilance and adaptation to stay effective. These points tie back to the overall theme of maintaining high standards through diligent, validated, and well-monitored practices. For further support, please don't hesitate to reach out to us through the contact information provided. We're here to help you with any questions or additional assistance you might need. Thank you so much for taking the time to be part of this presentation. We truly appreciate your attention and engagement, and we hope the information shared today has been valuable to you. Remember, we're always available to support your efforts moving forward. Thank you again.